Today, we're going to crack open the black box of one of the most talked about AIs on the planet, ChatGPT.
I mean, you type in a question and boom, out comes this incredibly human-like response. But how? How does it actually do that? What's really going on under the hood? All right, let's do this. We're gonna peel back the layers and take a look at the core ideas that make this whole thing tick. And we're gonna start with the most fundamental concept of all.
You might be surprised to hear this, but at its heart, ChatGPT isn't really thinking the way we do. It's actually playing an unbelievably sophisticated guessing game.
Stephen Wolfram just nails it with this quote. Think of it like a super-powered autocomplete on your phone. It's constantly just asking itself, based on pretty much the entire internet that I've read, what is the most statistically probable word to come next?
And here's the crazy part. It does this one single word at a time. It writes a word, then it looks back at the entire sentence it just created, and then it predicts the very next one. It's this constant loop that lets it build up whole paragraphs that actually make sense.
Okay, but to make those guesses so incredibly well, it needs a brain. A really, really big digital brain. And that, my friends, is where the neural network comes into play.
So just picture this digital brain made up of billions of these tiny interconnected neurons. Every single connection has a weight. You can think of it like a little volume knob. During its training, the AI tunes these billions and billions of knobs over and over until it learns to recognize the super complex patterns in human language.
And when I say billions, I mean it. The GPT-3 model, for example, has 175 billion of these tunable knobs or parameters. That is a staggering number, more connections than there are stars in the Milky Way galaxy, all working in concert to understand how we talk and write.
But wait a second, there's a big problem, right? Computers don't speak English, they speak math. They get numbers. So the very first challenge is, how do you translate our words into a language that the machine can actually work with?
Well, first, it chops up our sentences into smaller pieces called tokens. These can be whole words or sometimes just parts of words. This is really clever because it lets the AI handle brand new words it's never seen before, like over Pythonized, by just breaking it down into over, Python, and ized. Then each of these little tokens gets turned into a long string of numbers. That string is called an embedding.
Okay, and this is where the real magic starts to happen. These numbers, they're not random. They're basically coordinates that place each word on a giant invisible map of meaning. And on this map, words that mean similar things, like king and queen or dog and puppy, are located really close to each other. This is the beginning of how the AI starts to grasp the relationships between concepts. So we've turned words into coordinates on this incredible meaning map. But a sentence is way more than just a list of words, right? Context is everything. So how does the AI figure that out? Well, that's where the secret sauce comes in, an architecture called the transformer.
The transformer has a superpower, and it's called the attention mechanism. Think about how you read a long paragraph. You don't just focus on the one word you're looking at. Your brain holds on to the context of what came before. Attention lets the AI do exactly that. It can look back across the entire prompt, weighing how important every other word is to understand the true meaning of the current word.
And this example shows it perfectly. Thanks to attention, the AI can figure out that the word "it" is mathematically connected to the ball and not the robot. I mean, this is huge. This ability to track relationships across long stretches of text is the key to why its answers are so coherent.
All right, so we've got this incredibly powerful language model, but that alone doesn't make it a useful, helpful assistant. For that, it needs to go to a kind of finishing school.
And this is where we humans get back in the loop. It's a process called reinforcement learning from human feedback, or RLHF. Basically, real people look at a bunch of different AI responses to a prompt and rank them from best to worst. All of that feedback is then used to train a separate reward model that basically acts like a teacher, nudging the main AI to generate answers that are more helpful, safer, and just better. You can really see the difference this makes. On the left, you might have a generic, technically correct answer from the base model. But on the right, after it's been through RLHF, the response is way more helpful, nuanced, and better aligned with what the user was actually looking for. This step is what turns a text predictor into a useful tool.
And there you have it. That's a quick tour inside the digital mind of ChatGPT. If you found this useful, do me a favor and hit that like button and subscribe for more deep dives into the tech that's changing everything.
So I'm really curious, what part of this whole process blows your mind the most? Is it the insane scale, that 175 billion number?
Or is it that abstract map of meaning? Or maybe the attention mechanism? Let me know what you think down in the comments.